Hello everyone, in this video we're going to explore topic 9.4 defining and differentiating vector value functions of AB calculus BC. Alright, first we're going to talk about the vectors in a plane. To represent a vector, we use a directed line segment as shown right here. Alright, the directed line segments PQ has the initial point P and the terminal point Q. Two directed line segments that have the same length and direction are called equivalent. So you look at this one right here. This guy, equivalent, right? Now we call each a vector in a plane and write V equals PQ. Now V right here is the little v. Vectors are typically denoted by the lowercase boldface letters U, V, W. Alright, let's take a look at the first example. Let U be the directed line segments from 0, 0 to 5, 2. And let V be represented by the directed line segment from -1, 3, 2, 4, 5. Show that vector U is equivalent to vector V. Alright, to show that vector U is equivalent to vector V, you need to show that the direction and the magnitudes are the same. Alright, direction is the same thing as the slope. Right, now we need to find the slope of the vector U, right? So this one is S1, Y1. This one is S2, Y2, right? So the slope is Y2 minus Y1 over S2 minus S1, right? So it could be 2 minus 0 over 5 minus 0. It's going to be 2 over 5, right? Now vector V is going to be 5 minus 3 over 4 minus -1, right? So it could be 2 over 5, right? They're both the same thing, right? Now, magnitudes, which means we need to find the distance between 2 points right here, right? So it's going to be square root of y2 minus y1 square, right? Plus s2 minus s1 square, right? And then this guy turns out to be square root of 29, right? Now similarly, this one equals square root of 5 minus 3 square plus 4 minus -1 square. So it's going to be square root of 29. Now they both have the same values, right? So you can conclude that vector U is equivalent to vector V, right? Now, a line segment whose initial point is the origin and whose terminal point is V1, V2 is given by the component form of V given by V equals V1, V2. The components V1 and V2 are called the components of vector V. To convert directed line segments to component form or vice versa, use the following formula. Alright, if point P has P1, P2, point Q has Q1, Q2, then vector V represented by PQ in the component form is written as like this, right? Q1 minus P1, Q2 minus P2, right? And then the length of the vector V equals square root of this one right here, square, right? And then you're going to add them up, right? This is called the magnitude of the vector V. If vector V is V1, V2, then vector V can be represented by the directed line segment in the standard position from point P is at the origin, 2 point Q as V1, V2. Alright, now let's take a look at the second example. Find the component form and the length of the vector V having initial point right here and terminal point right here. Alright, so you have vector V is V1, V2, right? So it's gonna be -1 subtract 4, right? Comma 2 subtract -6, right? Alright. So it's gonna be -5, comma 8. Now, to find the magnitudes of this one, which means the length, right? So it's gonna be square root of this one right here, square, right? Plus this guy right here, square. Alright, so the answer is square root of 89. Now, we're gonna talk about the vector operations. Alright. First, if you add two vectors, you're gonna move one of them so that the initial sign of one vector is the terminal sign of the other vector. The sum u plus v called the resultant vector is formed by joining the initial point of the first vector to the terminal sign of the second vector. Alright, now I'm gonna keep vector u the same position. I shift vector v down like this and then up like this, right? So I'm gonna get this guy right here, right? Look, to add vector, we move one of them so that initial sign of this vector right here, right? The red vector right here is the terminal sign of the other, the terminal sign right here, right? See? Then u plus v is this guy right here. Subtract the vectors u and v. Now, vector u minus vector v is the same thing as vector u plus negative vector v, right? Negative vector v has the opposite direction of vector v, right? So this is the vector v, right? Now, negative vector v should be this one. So I'm gonna shift this one over here, so it could be like this. Alright, remember, to add vectors, we move one of them so that the initial sign of one vector is the terminal sign of the other vector, so keep that in mind. Then u minus v, right? Now, for vector u equals u1, u2, vector v is v1, v2, and the scalar k. This one is a constant, so keep that in mind. Alright, the following operations are defined. The scalar multiple of k and vector u is the vector k times u, right? So basically, you're gonna take vector u, you're going to multiply by k. Now, the vector sum of u and v is the vector u plus v right here. You just add their coordinates. Now, number 3, the negative of vector v is the negative vector v right here. So it's the same thing as -1 times vector v, right? So you're going to multiply -1 by each coordinates right here, right? Now, number 4, the difference of vector u and v is u minus v, and you just subtract their coordinates, right? Now, let's take a look at example number 3. Given vector u -3, 7, vector v is 5, 1. Find -1/2 times u. So you have -1/2. Vector u is -3, 7. right? So you just distribute this one, right? So you have positive 3.5, comma, negative 7 over 2, right? Now, question B, you're gonna take the magnitudes of this one, right? So you're gonna have square root of 3.5 square plus negative 7 over 2 square, right? So you're gonna simplify, it's gonna be square root of 9 over 4 plus 49 over 4, right? So it's gonna be square root of 58 over, now square root of 4 equals 2, right? Now question C, you're gonna add two vectors, right? So basically you just add this guy and this guy corresponding, this guy and this guy, right? So it's gonna be negative 3 plus 5, comma 7 plus 1, right? So it's gonna be 2, comma 8, right? Question D, you're gonna take the magnitudes of vector u plus vector v, which is you're gonna take the magnitude of this one right here, right? So it can be square root of 2 square plus 8 square. So it's gonna be square root of 68, right? Now 68 can be written as 4 times 17, right? So 4 you're gonna bring it outside, so it's gonna be 2 square root of 17, right? Now, question E, you're gonna take V subtract U, right? So it could be 5 subtract negative 3, comma 1 subtract 7, right? Alright, so it's gonna be 8, comma negative 6. Question F, you're gonna take the magnitudes of this guy, right? So it's gonna be square root of 8 square plus negative 6 square, right? So it could be square root of 64 plus 36, and it's gonna be square root of 100, and it's gonna be 10, right? Now question G, 3 times vector u is right here, right? So if you multiply by 3, you need to multiply each coordinate right here by 3. Multiply each coordinate of vector v by 4, right? 3 times negative 3 is going to be negative 9. 3 times 7 is going to be 21, right? Subtract 4 times 5 is going to be 20. 4 times 1 is going to be 4, right? Now negative 9 subtract 20 is going to be negative 29. 21 subtract 4 is going to be 17, right? Now question H, we're going to take the magnitude of this guy right here, right? So it can be square root of negative 29 square plus 17 square, right? Now square root of 29 square is going to be square root of 841. 17 square is going to be 289, right? So if you're gonna add this guy up, it's gonna be square root of 1130, right? Let's move on to the next one. We're gonna talk about the unit vectors. A unit vector has the same direction as the original vector, but with the length 1 only, right? If v is a non-zero vector, then the vector u is v divided by magnitudes of vector v is a unit vector. Now let's take a look at the example number 4. Find a unit vector for the vector v7, negative 3 and show that it has a length 1, right? So we have the unit vector is vector v, right? Which means 7, negative 3 divide by its magnitudes, right? Divide by square root of 7 square plus negative 3 square, right? So it's going to be 7 comma negative 3 over 7 square equals 49. 49 plus 9 is going to be 58, right? So then I'm going to rewrite this one as 1 over square root of 58 times 7 comma negative 3, right? Now you just distribute this guy. So it's going to be 7 over square root of 58 comma negative 3 over square root of 58. You either radicalize this one or you just leave it like this, that's fine, right? Now shows that the length is 1, right? So when we talk about the length of the vector, it's actually magnitude, right? So magnitude of vector u is square root of this one right here square, right? This one right here square, right? So it could be negative 3 over square root of 58 altogether square, right? So it turns out to be square root of 49 over 58 plus 9 over 58, right? So it's going to be 58 over 58. It's going to be square root of 1 equals 1. So it has been proved, right? Now, the unit vectors 1, 0 and 0, 1 are called the standard unit vectors and are denoted by I, 1, 0 and J, 0, 1. These vectors can be used to represent any vector V equals V1, V2, right? Now, V1 in the S coordinate, right? So you're gonna take V1 times the S coordinate right here 1, right? Y coordinate right here should be 0, right? Because when you multiply it's only V1. Now similarly, V2 is gonna be in the Y coordinate, so S coordinate must be 0, right? And then I just rewrite this one as I, right? And this guy right here as J, right? So I have this one right here. Now we call V equals V1 I plus V2 J is a linear combination of I and J. The scalars V1 and V2 are called the components of vector V, right? Now example number 5. Let U be the vector with initial point negative 3, 7 and terminal point negative 5, 2, right? And let vector V is 3i minus 2j, right? Write the following as a linear combination of I and j. Vector u is, right? Vector u is the vector with the initial point right here and terminal point right here, right? So you're going to take negative 5, subtract negative 3, right? 2 subtract 7, right? So you have negative 5 subtract negative 3, right? Don't forget to put I right here. Look, it's gonna be like this, right? Plus, similarly, 2 subtract 7, right? And this one should be j. Now we're gonna simplify. So this guy turns out to be negative 2i minus 5j. Done, right? Now question B. Vector W is for vector U minus 5 vector V, right? So this guy turns out to be 4 times this one right here. Negative 2i minus 5j minus 5 times vector V. Vector V is right here. 3i minus 2j, right? Now you just distribute, it's going to be negative 8i minus 20j. And then distribute this one is going to be negative 15i and plus 10j, right? Now you're going to combine like terms, this guy right here and this guy right here, right? So it could be negative 23i. And then this guy right here and this guy right here turns out to be negative 10j, right? Now let's move on to the next one. If vector u is a unit vector such that the angle theta is the angle from the x-axis to u, right? So this vector u right here, and the angle theta is right here, right? And the x-axis is right here. Then the terminal point of vector u lies on the unit circle, right? The terminal point is right here. It's gonna be right here, right? And is equal to cosine theta and sine theta, which is I times cosine theta and j times sine theta. If vector v is any other vector such that angle theta is the angle from the x-axis to vector v, then vector v is the magnitude of vector v times cosine theta sine theta, right? And then you just distribute the scalar, right? And you will get this one, right? Example number 6, writing vectors in component form. Write the vector v of length 6, making an angle 60 degrees with the positive axis in component form, right? So the component form is right here, right? So vector v is, you have the length right here, this guy actually absolute value of vector v, right? So it's going to be 6i cosine of theta, theta is 60 degrees, right? So cosine 60 plus 6j sine 60, right? Now cosine 60, you're gonna draw the unit circle right here, right? The x-axis represents the cosine function. The y-axis represents the sine function. Cosine 60 is the same thing as cosine pi over 3, right? Plus 6j sine of pi over 3. Pi over 3 is going to be somewhere right here, right? So if you project down to the cosine function, it's actually 1/2, right? So you have this one right here must be I, right? 6i times 1/2 plus 6j sine pi over 3 project down to the y-axis is going to be root 3 over 2, right? Times root 3 over 2, right? So you're going to simplify, it's going to be 3i plus 3 root 3j, right? Now let's move on to example number 7, application of vectors. Two tug poles are pulling a disabled cruise ship due east. One pulls with a force of 40 tons at an angle of 12 degrees to northeast, and the other at 50 tons at an angle of 18 degrees to southeast. What is the resultant force on the ship and what angle does it travel? Alright, so you need to get the x and y coordinate. Alright, so this one is the east side. This one is the north side. This one is the south side. And this one is the west side, right? Now, the disabled cruise ship is right here. Alright. Now we have two tug poles. One pulls with a force of 40 tons at an angle 12 degrees to northeast. So northeast, which means it's going to be this direction, right? So 40 tons at an angle 12 degrees, so it could be something like this, right? 40 and the angle right here 12, right? And the other is 50 tons at an angle 18 degrees southeast, which means this direction, so it's going to be negative, right? So be careful. So you have 18 is going to be something like this. 18 degrees. Now, what is the resultant force? So, go back to example number 6 right here. We have the formula is going to be right here, right? So, the resultant force F is, now, the knob is going to be 40 degrees, right? So, it could be 40 times cosine of 12 degrees right here, right? I plus sine of 12 degree J, right? If you want to write this one in the I and J component, right? Then the second one right here is going to be plus 50 degree times cosine of, now be careful, this is going to be negative direction, right? So it could be negative 18 degree I, right? Plus sine of negative 18 degrees J, right? Now I'm going to bring up the calculator. I'm going to press calculate. Then you need to be careful. This one is degree, but your calculator mode is radian. Alright, so you have two different ways to do it. You either convert this one to degree, which is not recommended because most of the problem on the IB exam, we're going to use the radian mode. So if you forgot to switch this one to radian mode, you're going to get the wrong answer for sure. So I strongly recommend you to leave this one as radian mode. Alright, now you still use degree with radian mode, right? So I'm going to press trick cosine 12. Now I'm going to press pi right here. I just put degree right here, and that's in my answer. It's going to be cosine pi over 15. I'm going to convert this one to decimal. So I'm going to press menu, number, convert to decimal, press enter. The answer is 0.978, right? So I have 40 degree times 0.978 I, right? Plus, now similarly, I need to calculate sine 12 degree, right? So I'm going to press trick sine 12 and press pi right here, put degree, hit enter. And then I need to convert this one to decimal, right? So I hit enter, the answer 0.207, right? Now you're going to do exactly the same thing for this guy, right? So I'm going to add 50 times, I'm going to combine like terms, right? So I'm going to take 40 multiplied by this guy right here, and then I'm going to add 50 multiplied by this guy, right? So you just use the calculator, right? The answer should be 86.679 I, right? Minus 7.134 J, right? Now you need to find the magnitude of the force, right? Square root of 86.679 square plus negative 7.134 square. The answer is 86.679 0.972, right? And don't forget the unit turns. Now you need to find the angle, right? So the angle is theta equals inverse tangent of y divided by s, right? Y values is right here, right? So it could be negative 7.134 divided by s value is right here, 86.679. Now we're gonna bring up the calculator. So we're gonna press check inverse tangent right here, and then press the fraction right here. Negative 7.134 over 86.679, right? And press enter. The answer is negative 0.0082 radian, right? Now if you want to convert this one to degree, you just multiply by 180 and divide by pi, right? So you have negative 0.082 multiplied by 180 divided by pi. The answer negative 4.705. So you look at this one right here, you see that it's going to be negative, right? So you need to say that the disabled cruise ship will move 4.705 degrees south of east, which is this direction right here, right? Now let's move on to example number 8. A plane traveling 500 miles per hour in the direction of 120 degrees encounters a wind of 45 miles per hour in the direction of 45 degrees. What is the resultant speed and direction of the plane? Alright, so we need to sketch the x and y coordinate, right? Plane traveling 500 miles per hour in the direction of 120 degrees. So 120 degrees should be right here, right? So this one is 500 miles per hour, and this one is 120 degrees, right? Now a wind has the speed of 45 miles per hour, right? So 45 miles per hour in the direction of 45 degrees. So 45 degrees is going to be right here, and it's going to be 45 miles per hour, right? So similar to example number 7, you have the resultant force. It's going to be F equals 500 times cosine of 120 degree I plus sine of 120 degree J, right? Plus 45 times cosine of 45 degrees I plus sine of 45 degree J. Now we're going to sketch the unit circle. The x-axis represents the cosine function. The y-axis represents the sine function, right? Now cosine of 120, so 120 is going to be right here, right? So when you project down to the x-axis, it's going to be negative 1/2, right? So you have 500 times negative 1/2 I plus sine of 120 is going to be right here, right? It should be root 3 over 2 J, right? Plus 45. Cosine 45 is going to be root 2 over 2 I. And sine 45 is going to be root 2 over 2 J, right? Now we're going to simplify. 500 times negative 1/2 is going to be negative 250 I, right? And then plus 250 root 3 j plus 45 root 2 over 2i plus 45 root 2 over 2j. Now I'm going to combine like terms. 45 root 2 over 2, I'm going to use the calculator. The answer is 31.819, right? And then I need to add negative 250, right? The answer is negative 218.8. Similarly, you have 250 root 3. Add 31.8198. Press enter. The answer is 464.833. Alright, now you need to find the magnitudes of the force. So this guy is the same thing as square root of negative 218.18 square plus 464.833 square. Alright, so I'm going to print up the calculator. I'm going to press square root of. The answer is 513.49. Now, next, we need to find the direction of the plane, which means we need to find the angle, right? So, angle theta equals inverse tangent of y divided by s, right? Y right here, s right here. Now, I'm going to print up the calculator. Press trig inverse tangent of 464.833 divided by negative 218.18 and then press enter. The answer negative 1.132, right? You need to be careful. The s value right here is negative. So when you calculate the inverse tangent of this one, you need to add pi radians, okay? Which is you learn in IB pre-calculus, right? So this one is the radian, right? Now if you want to convert this one to degrees, you're gonna take negative 1.132 multiplied by 180 divided by pi, right? Plus pi right here, which means 180, right? Now I'm going to print up the calculator. I have this value right here. I'm going to multiply by 180, right? And then divide by pi. Press enter. Then you need to add 180. Press enter. The answer is 115.114 degrees, right? Now you need to conclude that the plane will travel 115.114 from the horizontal, right? Or you can say that the plane will travel 115.114. You subtract 90 degrees, it's going to be 25.114, right? Degrees from west of north, right? This one is west and north right here. So it's going to go this direction right here, 25.114 degrees, right? Thank you for watching. I hope you enjoyed the video. Remember that if you failing to prepare, you're preparing to fail.
We rise like tall buildings. the chemicals that take us higher. The night's young, it has just begun, as she puts her hand in mine.